We have solved many equations that have x in the exponent by taking the log of both sides. The ones that we will do today will be ones that will involve using calculators on many of them. First thing we want to do is to make sure we remember this log property, because we will be using it quite a bit in these problems. So what would be the other side of this log property that we've used many times if we have log base b of m and then we've got an exponent? What's the way that we can rewrite that? Callum? So the exponent can come out in front and be multiplied by log base b of m. So keep that in mind as we work these. So first one that we're going to do is to solve 10 to the 2x plus 4 equals 7. So x is in the exponent on this, so this one is an exponential equation. So we need to take the log of both sides. So we have to decide log base what of both sides. So let me have some suggestions. Log base what? Which kind of log should we use on these? What's your best idea on this? What are you thinking, Elizabeth? So one excellent choice might be to do log base 10 or common log, so I don't really even have to write that base. 2x plus 4 is equal the common log of 7, because I know this will cancel out, and I will just have 2x plus 4 equals, and I can keep going. Other ideas? Anybody thinking we might have done it a different way with a different base? Because the answer is we could use any base, and it's correct as long as we take the same base on both sides. So we might have said we want to do log base 7 of 10 to the 2x plus 4 equals log base 7 of 7, so that it would have canceled out on this side and we'd have just 1. And we could do it that way. We could also do natural log. We could do natural log of 10 to the 2x plus 4 equals natural log of 7. And nothing would cancel out there, but we will see the steps with the help of the calculator where we could do it this way. So I want you to know you can do log base anything, and you're going to be making a choice that you think is best for that problem. We already talked about on this one, maybe log base 10 is the best because something will cancel, and that is the way we're going to finish solving this one. A disadvantage on a test if we had done log base 7. On your test, when I put your calculators in press to test mode, you can only access common log and natural log. You can't fill in log base 7 of anything. So you would not be able to do it this way that I wrote in red on your calculator on a test, only on homework. So we want to make sure we know how to do them on tests so we don't get in trouble there. So let's finish this one up. And log 7, if I enter that on my calculator, it's just going to give me some kind of a number for the answer, right? So that's just a number. It looks kind of messy, but it's just a number. So I have 2x plus a number equals a number. Come on, that's a pre-algebra problem, right? Let's isolate x. So Hope, help me out. What do I need to do to get x by itself? So I'll subtract 4 from each side, giving me log base 7 minus 4, and that was 2x. So then I need to divide by 2. Before you enter that on your calculator, a couple things of caution. This is not the log of 3. On your calculator, you're going to have a box. That 7 goes in that box. Be sure you move out of it before you do the minus 4. On these, I would like for you to do the fraction template, so you can enter your whole numerator and then your whole denominator and get your answer. So I need you guys to do that for me and let me know what answers we are coming up with on this thing. Holly, what'd you come up with? Anybody else? Negative 1.577? Yes, I'm seeing. Wait a minute. Does that work? Is that an argument of a log? Where was the x in the problem? Is it log of something with an x in it? Do we have to worry about that? No, x was in an exponent. Can we have negative exponents? Yeah, so we don't care in an exponent. So this is just fine, and this is our answer. Now, when you entered that common log of 7, what did you have to bother with on the calculator that was kind of a pain? As you entered it, what did you run into on those inspires trying to enter log 7? Oh. There was that little box for the base, right? And you had to either remember to actually put a 10 in it or to skip over it. Did anybody do log 7 and oops, that isn't where the 7 belonged? Because I do that all the time when I'm entering common logs on those Inspire calculators. So you have to be careful when using common log. But on ones like this, it is probably the best choice because so much does cancel out there. So let's move on to another example. So x is part of the exponent, so this is an exponential equation. So we need to solve it by taking some sort of log of both sides. So Billy, what kind of log do you think would make sense to take on this problem? Why? So on this one, we're going to take the natural log of both sides because that will make the e go away. And we just have 4x plus 1 on the left equals the natural log of 33. Same idea as the last problem, right? Because ln 33, the calculator knows it's just some number. So ln 33 minus 1 would be 4x. Divide both sides by 4 and get x. Again, be sure you write this down with a fraction bar. I want to see that work of exactly what are you typing into the calculator. That's how I know where you went wrong if there's been a mistake. So let's punch that one in and see what we come up with for an answer. Allie, you have it already? Gina, you have it? Anybody else? 0.624? Thumbs up, thumbs down. Is that what we're getting? So this time we were entering ln, and what did you notice as you were entering natural log on the calculator? What? No box for the base to worry about. It's a little bit more efficient to enter it. So if everything else is equal in a problem, and your only choices on a test are common and natural log, you might want to go with natural log so that you don't have to worry about that little box. Okay, questions there? Okay, let's do one where we really get messy. So another exponential equation. I have x's in the exponents, but I've got them on both sides, so it's not quite so nice. So what base do you think makes sense to use when we take logs for this one? Log base what? And there's more than one correct answer. Tessa, what are you thinking? I could do either log base 2 or log base 5 if it's homework and not press the test where I can't do that as a base, and that would cancel it on one side or the other. Let's suppose, though, we do get one like this on a test. That means our choices are natural log and common log. Evan, what are you thinking? I could do common log, log base 10, or I could do natural log. And before you punch anything in your calculator on this one, wait, because I'm going to divide the room so that you don't end up having to do it twice. I'm going to have some of you enter it one way and some the other. We could do it either common or natural log. I'm going to choose on this one to do it with natural log because that way I'm only having to write 2 letters, ln, instead of 3, log. But then at the end I'll convert it, so if we'd done it log, you'll know what to have entered on your calculator. So if I take the natural log of both sides, now we're back to that log property we reviewed at the very beginning, natural log of 2 to a power. So I'm going to bring the power out in front, x minus 4 times the natural log of 2. Is that correctly written? And I'm glad to see some heads shaking no. Tell me why this is not written correctly, Morgan. This means x minus only the 4 times the natural log. But it's x minus 4 both getting multiplied by the natural log of 2. So I must have the parentheses there. And natural log of 2 is just one number. You don't have to have parentheses around it, but it is only one number. And then same thing on this side. Bring the 2x minus 1 for that exponent out in front, and that gets multiplied by the natural log of 5. Now, ln 2 is just a number. So I have a number times a parentheses. Same thing on the right-hand side. I have the parentheses times just a number. And we know when we have number times a parentheses, we can distribute. So I'm going to say I have x times the natural log of 2, so that's just a number times x, minus 4 times the natural log of 2, that's just a number. On the right-hand side, I'm going to have 2x times the natural log of 5 and minus the natural log of 5. So on the left, I have something times an x and something that's just a constant number. Messy number, but just a number. Same thing on the right. And when I have an x term on each side and a constant on each side, I need to get the x's together on one side and the constants on the other. So if I subtract the 2x ln 5, I'll have the x ln 2 minus 2x ln 5 on the left. Those are both of the ones with the x's. On the right, I'm going to need to add the 4 ln 2. So that's a positive over here. The minus ln 5 stayed put. And we've done plenty of other ones where, okay, we need to get the factor the x out. So we will have x times ln 2 minus 2 ln 5 over there on the left. And then what do I need to do if I want to get just x? Catalina, what do I need to do? How about divide by that whole parentheses? So if I divide by that parentheses, I have this. Don't enter anything on the calculator yet. And when I divide here, that means just x is equal. So far, so good. A couple things I want to point out before we enter this on the calculator. Please don't try to do too many steps as mental math. What I saw a lot of the last couple of periods, because there's one of these that I'm stamping for you to make sure you've got it right, the mistakes were a plus or a minus sign because of people trying to do too much of this in their heads and getting one of those messed up as they moved things left and right. I also must see this long fraction bar, what you are entering in the calculator. You do the work by hand till you get to this step. Do not do it like in the book. The book does all of this stuff rounding off to different numbers along the way. We're going to go all the way to here so it's exact and then enter that all in one step. I hope nobody has started entering this because I have not yet divided the room in half for this one. So I want everybody on these 3 rows, so the rows closest to the hall, I want you to enter this with common log. So 4 log 2 minus log 5 over log 2 minus 2 log 5. The steps would have been the same. We would have just had log all the way down. Everybody else in the 3 rows closer to the windows, enter it with natural log like you see here in the red, and we should get the same answer both ways. Why, some of you over here have gotten done fast. They're still typing. Giselle, what do you have? Negative 0.461, both ways. Why'd they get finished faster? Because why? Why did the natural log people come up with negative 0.461 slightly faster? What'd you guys have to mess with doing the common logs? You had to mess with that box for the base all 4 times, either skipping over it or putting a 10 in there. They didn't even have a box come up at all when they did natural log. So if everything else is equal, you may want to do natural log instead of common log. Let me go back. We've got one more problem that we'll do here in a moment. Let me just go back to this one very briefly. If I had done natural log on this one this way in blue, I would have ended up with, let's see, 2x. I would have had a 2 ln 10, and I would have had a minus 4 ln 10. So yes, I would have had ln's, but I would have had 3 of them in that problem. So it's kind of a trade-off. If you do ln's, when you have a base of 10, if you do ln, you'll have more of them, but you won't have to skip over that little box for the base. If you do common log, you'll have fewer, but you will have to deal with that little box in there for the base. Questions to that point? All right, nobody touch a calculator now. Some of your problems will be no calculator. And we have to figure out how we're going to do this without a calculator. I could do common log of both sides, but I don't know how to do that in my head. I could do natural log of both sides, but I don't know how to calculate natural logs in my head for a problem like this. So help me out here. What can we do? We cannot use a calculator. You will have ones kind of like this that I mark on homework as a no calculator problem, and you will have ones like this that show up on the no calculator part of your test. So what can we do? Gavin, what are you thinking? Why 2? Each of the bases are powers of 2. So you're exactly on the right track. Great job. You want to look at those. Can you rewrite them with the same base? And noticing that 4 is 2 squared and 8 is 2 cubed, we can then say 4 to the x plus 3 equals 8 to the 2x minus 1. Before we take logs on both sides, let's simplify those. When you have x to one power to another power, what do you need to do with those powers? Jen, what do we need to do with the powers? We have to multiply them so that we get 2 to the 2x plus 6 equals 2 to the 6x minus 3. Did I get that right? Then we can take log base 2 of both sides. And now it's a really, really easy pre-algebra problem that 2x plus 6 equals 6x minus 3. Get the x's together, so 4x, add the 3 to both sides, and x is 9 over 4. So questions with that? Oh. No. We've seen, she asked if you have to write log base 2. We've seen that if you've got the same base to an exponent, you can just set the exponents equal. The reason for that is you're taking the log with the same base of both sides. Anything else?